This is Mrs. Wayner's Math Class, Chapter 11, Lesson 11. Find the volume of composed figures, Part 1. Today's learning target: by the end of the lesson, you should confidently be able to say, I can find the volume of rectangular prisms that are combined. Let's take a look at example number 1. It says the shape at the right is a composite figure. It is made up of two rectangular prisms that are combined. How can you find the volume of the figure? Well, if we look at this figure right here, it definitely doesn't look at like one rectangular prism. It actually looks like an L, right? And we know the formula for volume of a rectangular prism is length times width times height. But if this isn't a rectangular prism, we can't use that formula. But if I look at this L shape, I can kind of cut it and separate it right here to make two separate rectangular prisms, one on the top and one on the bottom. Then we can find the volume of each separate rectangular prism and add those volumes together. That would give us the entire volume for this combined composite figure. Let's see how it's done. So if I take this figure and I shade each new separate rectangular prism, the top one in green, and I'll label that rectangular prism A, and the bottom one in blue, I'll label that rectangular prism B, we can then find the volume of each separate rectangular prism and add them together. And although it's on paper and I can't actually physically do it, in my mind I can kind of separate prism A and prism B, as you see here in step 2. It's kind of like I took them apart as the two separate prisms. And when I have separate prisms all by themselves, I know how to find the volume. That's volume equals length times width times height. So I'll solve for rectangular prism A first. And as always, I'm going to write my formula. V for volume equals L for length times W for width times H for height. We always write our formula before we do the volume. Then I will rewrite my V for volume, and I need to figure out what my length is. Well, remember, the length is the left to right. So in green rectangular prism A, my left to right is right here, so my length is 2 inches. I'll write a 2 for length. Times, I need to figure out my width. My width, remember, is from front to back. So I can see right here in pink the front to back section, and that's labeled as 4 inches. So that's my width, 4. Times the height is bottom to top. So if I look over here, I see my bottom to top. The only problem is it doesn't tell me what the height is. I don't see on any of the sections of this green rectangular prism what the height is. So let's look at the figure back above it, the actual composite figure that we got in step number 1, where A is green on top and B is blue on the bottom. And in that composite figure number 1, I see on this left side a line, I just labeled it in yellow. That includes the height for A and B, and I know that the height for the total of A and B is 6 inches. Well, look at that composite figure again and find out if there are any other heights shown in that composite figure. And I see on the right side there's another height, and that says 2 inches. Well, if A and B combined is 6 inches, and the height of B by itself is 2 inches, can't I then just say 6 for the total minus 2 for the blue equals 4, and that's what the height of the green will be. So sometimes when you have composite figures or combined figures, you need to be almost like a little detective or a little sleuth to figure out what the measurement is. Take my total of A and B, 6, minus my height of B, 2, and the difference will tell me what the height of A is. So the height of A is 4 because 6 minus 2 equals 4. And therefore my height is 4. Okay, so now I'm going to go ahead and bring down my V for volume, and I will multiply 2 times 4 equals 8 times 4, and 8 times 4 equals 32. My unit is inches, and since it's volume, I'm multiplying 3 things, therefore it will be cubed, so it's inches with that little fairly odd parent of a 3 for inches cubed. So the volume of figure A is 32 inches cubed. Now let's figure out the volume of figure B. So I'll write down my B, and I always write down my formula. So volume equals length times width times height. Bring down my V again, and I need to look for my length. Again, remember my length is left to right. I see an orange here, my left to right. So this is my length, which is 10 inches. I'll write down 10 times my width is front to back. And I see in pink here, front to back is 4 inches. So my width is 4. I'll write down 4. My height is top to bottom, and I see it is listed right over here. I wrote it in gold. There's the line. That is 2 inches. So the height for the blue figure, or figure B, is 2 inches. So I'm going to say 10 times 4 equals 40, and it's going to be 40 times 2. And we know how to solve this because we can simply do basic facts. Basic facts are 4 times 2 is 8. Tack on the 0, 80. Again, my unit is inches, so that would be inches cubed. So we figured out the volume of figure A, we figured out the volume of figure B. In order to find the volume of the entire picture, as was given to us up at the top, we need to put those two volumes together. And again, in order to do this, we'll take the volume for figure A, which was 32, the volume for figure B, which was 80. Make sure we line them up properly. Let's add them together. 2 plus 0 equals 2. 3 plus 8 equals 11. So it's 112. Again, very important. Inches, which is my unit, and cubed since it's the answer to volume. And that's how we find the volume of a composite figure. Find a place to separate it, so you can separate it into two separate rectangular prisms. Separate it, do the volume of each separately, and then add those volumes together. Please stop the video and complete worksheet number 1 right now. Remember, you can go back and do it with me step by step with this video. Let's take a look at example number 2. It's another composite or combined figure. It's certainly not one full rectangular prism because on the right side is a little bit smaller than the left side. So where could I separate this? Where could I draw a line to separate this so that I could make 2 or more full rectangular prisms? I think I can put a line right here. It's almost like cutting it right down there and separate it into 2 rectangular prisms. I would have on the left side a rectangular prism. I'll label it A. I always like to label my separate rectangular prisms. That would be my larger rectangular prism. On the right side, I'll label it rectangular prism B. That would be my smaller rectangular prism. If I find the volume of A and the volume of B and I combine them together, I will find the combined volume of the composite figure. Okay, so let's find the volume of A. Of course, first thing we need to do, we know, is write the formula. So volume equals length times width times height. And I need my length. My length is my left to right. Well, on figure A, I see in blue my left to right section. And right underneath that, I see a measurement. Remember, the measurements are always in the center of the line. So that means that my length will be 5 centimeters. I put a 5 under length. Now I'm going to multiply that times my width, which is from front to back. Where on figure A, the larger rectangular prism, do I see a measurement for front to back? Here it is right over here in orange. So my width will be 4 centimeters. Write down 4 under width. Finally, I need to multiply that times my height, which is top to bottom. Where on figure A do you see a measurement for the height from top to bottom or bottom to top? And here it is right over here in green on the left-hand side. My height will be 2 centimeters. So I'll write down the 2 under height. I'm ready to go ahead and multiply. I'll do 5 times 4 first. That's going to equal 20. Bring down my times 2. And basic facts, 2 times 2 is 4. And tack on that 0, giving me 40. Notice in this problem my unit is centimeters, so that would be 40 centimeters cubed. So now that I've found the volume for figure A, let's focus in on the smaller rectangular prism, figure B. And as always, we know I'm going to write the formula, volume equals length times width times height. I'm looking for my length, and I'm going to see that purple line right underneath B. That's my left to right, and I see a label there, so I know my length is 3 centimeters. So volume equals, put a 3 under the length, times my width is my front to back. So I see in yellow that's my front to back with a 2. So my width will be a 2 centimeters. Times my height is a top to bottom. I need a top to bottom for B that has a measurement. Well, I see top to bottom here, but there's no measurement. And I see another pink top to bottom there, but there's no measurement. And I see another pink top to bottom there, but there's no measurement. Well, when this happens, and it will happen very often on combined figures, I need to find someplace else in the picture another measurement of the exact same height. It may not be in the figure that I'm looking at, may not be in figure B, but I might be able to find something in figure A that has the exact same height. And if I look over here on the left-hand side, nope, there's nothing right there in figure A, but I move all the way over to the left and I say, that is the same height as all of the heights so far, because A and B are the same height straight across, right? You can see that they're even from bottom to top or from top to bottom. So I know that the height is the same as it is right over here on my left-hand side. So my height for figure B is also 2 centimeters. I'll put the 2 underneath. So I'll multiply my 3 times 2, which equals 6. So my volume is going to equal 6 times that leftover 2, and 6 times 2 equals 12. So the volume equals 12. Again, my unit is centimeters, and it's volume, so it's cubed. In order to find the total volume, I need to add together A plus B. Well, A is 40 centimeters cubed, plus B is 12 centimeters cubed, and 40 plus 12, let's see, 0 plus 2 is 2, 4 plus 1 is 5, so that's going to be 52 centimeters cubed, and that's my total combined volume for number 2. Please stop the video and complete worksheet number 2 right now. Let's take a look at example number 3. Oh boy, this one looks interesting. Well, it's definitely not one rectangular prism, so I cannot do my regular volume formula. There would definitely be spaces that are missing on the top left-hand side and the top right-hand side. Well, let's see. If I try and separate it and put a line right there, I will have a prism on the left, but the prism on the right is also not a rectangular prism, because all the way to the far right, it's still missing some. It almost looks like a big fat L here. So for this one, I'm going to need to make another line. And if I separate this into 3 sections, I will have separated it into 3 actual rectangular prisms. Again, I can find the volume of all 3 prisms, add those volumes together to get the combined volume. So as always, let's label our prisms. I have prism A, prism B, and prism C. The first one I'll concentrate on is prism A. When it gets into a lot of pictures here, I like to either trace it out or highlight my prism. On mine, the highlight kind of covers everything over, so I'm going to trace it out for us in this video lesson. So for figure A, this is what it would look like right here. And that would be the whole rectangular prism. Notice on the top right-hand side, I didn't put the line in because it's kind of covered by prism B, because prism B is taller. But basically that's what prism A looks like. So I'm going to write down A, and as always I'm going to write down my formula. Volume equals length times width times height. My length is my left to right. So let's look at figure A and see if there are any left to right lines that are labeled. And I see right over here, volume equals, right at the top, as I highlighted in yellow, that's a left to right line, and right above it is labeled 3 feet. So now I know my length will be 3. Put that under the L. Times width is front to back. And when I look over here in orange, there's a front to back, but it's not labeled. And I don't see any other front to backs on A. So what am I going to do? I know there's one kind of hidden on the right side because it's hidden by B, but I can't see it, so that doesn't help me. Well, let's take a look at this front to back right here. I might think that that's 3 feet, but remember what we learned. The measurement is always going to be labeled right smack dab in the center of the line, and that 3 is not in the center of that orange line I just wrote. It's in the center of that yellow line. So that 3 is for this line right here. All right, we need another front to back for my width. Here's another one, but it's not labeled either. Keep going. Here's another one, but no label there. Here's another one, but no label there. But aha, I found it. Another front to back that does have a label. So my width will have to be 5. Put a 5 under the width. Times my height is bottom to top. So let's go back to figure A, since that's what I'm working on, and see if there's a line that goes from bottom to top or top to bottom that's labeled. And here it is in pink right here, so I know that my height will have to be 4. So put a 4 under the height. So now I'm going to go ahead and solve this, and I'm going to choose to say 5 times 4 first. Why? Well, think back to chapter 1, properties of multiplication. You can multiply in any order and still get the same answer. I could have said 3 times 5 first, but that would have given me 15, and I don't know my 15 times tables. And I could have done it, but I would have needed some scrap paper. But I kind of thought it out and looked ahead and I said, well, 5 times 4 is 20. That ends in a 0. That's going to make my life much easier. So I chose to do 5 times 4 first. So my volume equals, well, 5 times 4 is 20. We always solve for a circle. Bring everything else down. So bring down my 3 and my times. And now when I go ahead and solve this problem, I have basic facts. So my volume equals, basic facts, 3 times 2 is 6. And tack on the 0. So my unit is feet, and this is a volume problem. I'm multiplying 3 numbers, so I know it has to be cubed. So the volume for figure A is 60 feet cubed. Now let's see if we can find the volume for figure B. I'm going to go back to my diagram and erase the lines that we drew in so that we can just focus in and concentrate on figure B. Okay, so let's focus in on figure B. This would be the front of the rectangular prism for figure B. This would be the top of it. And on the side, it kind of stops right there where figure C is, but I know it's not empty or it would crash right down. So I'm just going to kind of do some dotted lines to show where this would have to be for figure B. Okay, so for figure B, again, I want to find the volume of this full rectangular prism. So I'll write down B. Of course, I'm going to write down my formula. Volume equals length times width times height. Now, for my volume, I need my length, which is my left to right. Notice something, because this can be tricky in composite figures, and it happens frequently. Remember, when we first looked at this composite figure, it was one figure. It was not separated into A, B, and C. So on the bottom right here, this full length of the line, that's what that 12 feet stands for, because it stands for what was there originally, which was the one long line. Don't let that trick you. I cannot use 12 feet because that's the total length of A, B, and C together. So let's see for rectangular prism B if there's a line that's labeled for my length from my left to right. And if I look all the way at the top, I see one right there. I just highlighted it in yellow. So my length will be 5. Put a 5 underneath the L. I'm going to multiply that by my width, which again is front to back. I look over here on my left-hand side in orange and I see a front to back. But remember that 3 feet, the 3 itself is not in the center of that line. It's at the corner of it. So that 3 has to stand for this line right here. It cannot stand for my width. Well, what's another width I have for rectangular prism B? Here's one, but again, no measurement. Here's one, but again, no measurement. So I have to look at the other figures and see if I can find the same measurement. Notice that A, B, and C are all have the same width from front to back. So keep going. I see one right there, front to back, and again, it is 5. So my width will be a 5 times the height. Remember, the height is from bottom to top or top to bottom. So let's see for figure B. Here, I just highlighted in pink a top to bottom, but there is no measurement for it. Here's another top to bottom, but there is no measurement for it. So I need to see if I can find someplace else on this figure that will help me figure out what the height is for B. I look all around. Oh, look all the way on the right-hand side here. It shows me by this line that the very bottom to the very top, and it is the very top of B as well, is 8 feet. Therefore, my length will have to be 8 feet. So I'll put the 8 under my height. Now I'm going to move down to my next line, and I'm going to choose again to look ahead. If I had said 5 times 5, that equals 25. Maybe if I'm good with quarters, I know my 25 times tables. But I see that if I do 5 times 8, I know that equals 40. It ends in a 0. And then I can do basic facts. So I'm going to choose my 5 times 8 first. So my volume equals, well, 5 times 8, solve for my circle is 40. Bring down my other numbers, which are 5 and times. And now I'm going to do 5 times 40. So my volume equals, basic facts, 5 times 4 is 20. Uh-oh, there's an ending 0. Underline it so I don't get confused with that ending 0. And now tack on the 0 from the 40. Again, this is feet. So the volume for rectangular prism B is 200 feet cubed. Now let's take a look at rectangular prism C. So for rectangular prism C, let's trace it out. This would be the front, this would be the top, and this would be the side. That's all we would see of rectangular prism C. So let's find the volume for rectangular prism C. As always, we're going to write out our formula. Volume equals length times width times height. We need to find our length first. Our length is our left to right. Well, in rectangular prism C, I see this 2 feet in the center there. Which does that 2 stand for? Well, remember, the number is always right smack in the center of the line. So that 2 is really only in the center of this line right here, which is a height line. So that's not going to help me for length. Length is going to be my left to right. So let's see. I remember that the 12 feet down here is the full length, because when they first gave me the figure, I had not separated it into boxes A, B, and C. It was one plain figure. So the 12 is not going to be my length for C either. Well, let's see what else I can find out. I know that a length for C would be right there in the bottom in yellow, but it doesn't tell me what it is. Or that would be another area to find my left to right length, but it doesn't tell me the measurement. And that would be another area to find the left to right length, but it doesn't tell me the measurement either. If I look at rectangular prism A and B, maybe I could give a wild guess that one of them are the same length, but I really don't know for sure. There's nothing to really prove to me that they're the same length. Well, let's see what I do know. I do know that the entire length of A, B, and C together is 12 feet. I do know that the length of B is 5 feet. And I do know that the length of A is 3 feet. So if I take my 12 feet, I take away A, which is 3, and I take away the length of B, which is 5, I can figure out whatever my difference is, and whatever the difference is will be the length of rectangular prism C. So 12 minus 3 equals 9. Bring down my minus 5. 9 minus 5 equals 4. So the length of C has to equal 4 feet. And that makes sense, right? Because if I add up all the lengths, 3 feet for A plus 5 feet for B equals 8 feet, plus 4 feet for C will equal 12 feet, and of course that's my total length. So that sounds like it makes lots of sense and is the correct answer. So under letter C in green, under my length, I'm going to put a 4. Now I have to multiply by the width. The width, remember, is front to back. And I see right over here, I put in orange, my front to back is labeled for me. That's going to be the 5 times my height, which is going to be bottom to top. And let's see if I can find the height here. Well, bottom to top. I see in pink there's a bottom to top right there. And I had figured out earlier that the 2 is right smack in the center of that line. So I know my height has to be 2 feet. I'll put the 2 under height. I'm going to go ahead and multiply, and I see if I multiply 4 times 5, that's a 20, which ends in a 0. I like that, so that's what I'm going to choose to do first. Bring down my times 2. Now I'm going to multiply this part out, and volume equals basic facts. 2 times 2 is 4, and tack on the 0. Again, my unit is feet, and this is volume, so it will be feet cubed. So I've now figured out the volume of rectangular prism A, rectangular prism B, and rectangular prism C. But I need the total volume, and in order to find that total volume, I'll have to add all of those rectangular prisms together. So A plus B plus C. Well, I remember that A is 60 feet, so I'll write down 60. B was 200 feet. I'm going to line up my place value columns. And C was 40 feet. Again, line up my place value columns and add all of these together. So I get 0 plus 0 plus 0 is 0. 6 plus 0 is 6. Plus 4 is 10. Put down the 0, carry the 1. 1 plus 2 is 3. And once again, my unit is feet and its volume, so it's feet cubed. And that's my final combined volume, 300 cubic feet. You can stop the video and complete worksheet number 3 right now. Example number 4, I need to find the volume of this composite figure, and that's definitely not a rectangular prism, so I'm going to need to draw some lines and separate it into separate rectangular prisms. I can draw a line right over here, and that would give me one rectangular prism on the top right hand side, but what's left is not a rectangular prism, it's actually an L. So again, for this one, I'm going to need to divide it into 3 separate sections. Now I have rectangular prism A, rectangular prism B, and rectangular prism C. Let's focus in on rectangular prism A first. So again, I'm going to trace rectangular prism A so we can see as much of it as we can and really focus in on it. This would be the front of rectangular prism A. I see my side over here comes back this way, and it goes down basically right about that direction. I know it is actually 3-dimensional. I just can't see the bottom or the right side or the top, but I know that it is like a block or a rectangular prism. So I'm going to write down A and find my volume for A. As always, when I'm finding the volume, I write the formula: volume equals length times width times height. My length is going to be my left to right. So let's look at figure A and see if we can find a left to right line that's labeled. And there it is, right there in yellow. That length will be 3 inches. So now I need to find my width. My width is my front to back. I see a width right over here, but there's no measurement for it. And I don't see any other width on figure A. So I need to look on the other figures and see if I see a same front to back width. When I look at this entire composite figure, I see that there's no part that sticks out forward further than another part. So my width of the entire figure is the same. My front to back is the same. Let's find some other front to backs then and see if we can find a labeled one. Here's a front to back, but it's not labeled. And here's one, oh, that is labeled, so my width will be 4. Put 4 under my W for width. Now I'm going to multiply that times my height. My height is bottom to top or top to bottom. Look at figure A and see if we can find a top to bottom line that's labeled. And there it is, I lined it in pink, so my height is going to be 6, and I'll write that right in under my H. I'm ready to solve this, and I look at it ahead and I say, if I do 3 times 4, that equals 12, and I know my 12 times tables. So that's how I'm going to solve this. I'm going to say 3 times 4 first. So 3 times 4 equals 12. Bring down my times 6. 12 times 6 equals 72. And the units are inches, so it's going to be 72 inches, and of course it's volume, so it will be inches cubed. So the volume for rectangular prism A is 72 inches cubed. Let's take a look and focus in on rectangular prism B next. So if I focus in on B and trace that, this would be my front face of figure B. This would be my bottom of figure B, And I can kind of see in my brain that on my left-hand side, I would cut it that way and bring it right down there. So this is the figure B that I'm looking at. Okay, so let's find my volume for a rectangular prism B. As always, when I'm finding the volume, I write down my formula, volume equals length times width times height. Let's find my length first, or my left to right. So if I look at rectangular prism B, do we see any left to right lines that are labeled? Oh, all the way in the bottom I see one right here. So this label is 12, therefore my length is going to be 12, and I'll put that down under my L. Next I have to find my width, which is my front to back. Look at rectangular prism B and see if you find any front to back lines that are labeled. Right on the right hand side here I see this front to back line that's labeled 4 inches, so I know that my width has to be a 4. Put 4 under my W for width. Finally, I need to find the height of figure B, and that's bottom to top or top to bottom. So let's focus in and see if we can find the height of figure B. Figure B I traced in purple. So right here on my right hand side I made a pink line, that's my height, but it doesn't have any number by it. Over here on the left hand side in pink, that's a height, but it doesn't have any number by it. And all the way on the far left, that's another height, but it doesn't have any number by it. And there's no other figures exactly as high or as tall from bottom to top as B, so I'm going to need to look around and see what I can figure out. Well, let's take a look at all of the heights that I can see. And oh, look what I see all the way here on the left-hand side. I see the entire height of A and B together is 8 inches. And I also see that the height of A right over here is 6 inches. So if I take my entire height of A and B, subtract A, take it away, what's left should be the height of B. So I'm going to say 8, take away the 6, and 8 minus 6 equals 2. Therefore, the height of figure B must be 2 inches. And that makes sense because A plus B, 6 plus 2 equals 8, and that's the height of the entire thing. So I'm going to put a 2 underneath my H for height. Now let's go ahead and do the math. So I'm looking ahead. I see if I did 12 times 4, I know that's going to be 48. But then 48 times 2 I don't know by heart. But if I do 4 times 2 first, that will be 8, and I do know 12 times 8 by heart. So that's what I'm going to do. 4 times 2 is 8. Bring down my 12 and my times. And 12 times 8 equals 96. Again, my unit is inches, and it's volume, so it's cubed. So my volume for rectangular prism B is 96 inches. Let's focus in on my last rectangular prism, which is rectangular prism C. So this would be my front of rectangular prism C. This would be my side. This bottom part of my side, I really can't see. It's hidden by rectangular prism B, but I'll just draw that in right over there. And if I want to find the volume for rectangular prism C, I always write my formula for volume. So volume equals length times width times height. First thing I need to find is my length, my left to right. Let's take a look at figure C and see if we can find a left to right line that tells us the length. Well, I see one right here on the top, so my length is going to be 3. So my volume equals, put a 3 under the length and my times sign. Next I need to find my width, which is my front to back. Let's look at rectangular prism C and see if we can find a front to back width. Well, the only front to back width on C that I see is right here in orange, and that does not have a measurement on it, because remember that 4 that's on the left hand side is not in the center of that line, so it cannot be a measurement for that line. So let's look at the other rectangular prisms. Are there any other front to back measurements that are the same? Well, my front to back, or my width, is the same for the entire figure for all A, B, and C. Let's take a look at A. There's a front to back, but again there's no measurement. On the bottom here's a front to back, but there's no measurement. But on the bottom right hand side right there, there's a front to back and there is a measurement, so my width will be 4. so I'll put a 4 underneath width. And let's take a look at rectangular prism C to see if we can find a height, a bottom to top or top to bottom line that has a measurement. Oh, good news. I see one right here. I showed it in pink. So my height is going to be 4 inches, and I'll put a 4 underneath height. And as I get ready to multiply, I look ahead and I say, well, if I do 3 times 4, that's 12, and I know my 12 times tables, that's good. So that's what I'm going to solve first, is my 3 times 4. So my volume equals 3 times 4 is 12. Bring down my times and my 4. Go ahead and solve that. 12 times 4 equals 48. So my volume equals 48. My unit is inches. And since I did volume, that would be inches cubed. So I now have my volumes for rectangular prism A, B, and C. Let's add them together to find the total. A is 72 inches, so I'll write down 72. B was 96 inches cubed, so I'll write down 96. C was 48 inches cubed, so I'll write down 48. And I'm going to add them together. Remember back in chapter 1, our properties of addition. See if you can find partners of 10. Well, I see that 2 plus 8 equals 10, plus 6 equals 16, so I'll put down the 6 and carry the 1. Now in this next column, I see 1 plus 9 equals 10, 10 plus 7 is 17, and 17 plus 4 is 21. So I have 216. And my unit is inches, and of course it's volume, so it's cubed. So 216 inches cubed is my total composite volume. Please stop the video and complete worksheet number 4 right now. So let's review. To find the volume of a composite figure, you often need to separate the figure into separate rectangular prisms, because volume equals length times width times height only works for an actual rectangular prism. So in this example right here, we cut it in half. Remember, when you cut it in half, you're picturing yourself making 2 separate rectangular prisms, as shown here in the green A rectangular prism and the blue B rectangular prism. And in your mind, you can kind of separate them into the separate rectangular prisms as shown here in step 2. Right? If you look at it, you separate it in your brain into 2 rectangular prisms, you can then find the volume of each prism. You'll do one prism at a time, remembering the formula for volume for a rectangular prism is volume equals length times width times height. We always write our formula. The length will be our left to right. In this case, it was the orange 2. Width will be our front to back. In this case, it was the pink 4. And height will be bottom to top or top to bottom. Sometimes when you have composite figures, actually very often when you have composite figures, you won't have every measurement needed, so you'll need to almost be a sleuth or a detective to use the clues that are given to you to figure out the missing measurement. In this case, we looked up at the top and we said for our height, we knew the total height of A and B together was 6. We knew the height of B all by itself was 2. So we said 6 for the total, take away 2 for B, will leave us with what A's height is. And that left us with the fact that the height for A was 4. Once we're finished, we go ahead, multiply, and find that total volume. And then, of course, we're going to do the same thing for the next figure or figures, depending on how many there are. Once you've found the volumes for all of the separate rectangular prisms that you've separated it into, you add each of those final volumes together to get the total volume of the figure. In this case, the volume for A was 32. The volume for B was 80, so we added those together, and we got 112 inches cubed. Remember, you always need to have the unit, and it always needs to be cubed for volume. Good luck with this lesson.